So, hello everyone. I'm Johannes Hefter. I'm a software developer at Infosym, and I will present to you basically two topics, one being time series databases and the second being the Kafka integration with StableNet, since it works quite similar under the hood. Inside StableNet, we put this together into one presentation. And I'm starting off with some slides regarding time series databases, basically just picking up where Marius left off in his keynote speak. So yeah, time series databases, it's the same definition, telling us, okay, it works well for timestamp data and time index data, doesn't matter if storing or accessing. And this is not only the definition, but this was also the motivation for doing all of this. Because yeah, we have lots of measurement data. Why not improve a bit the performance of StableNet in different areas? So we started off with that. And of course, we wanted to see what advantages can we get out of it, but also which limitations do we get in theory, but also when using it in practice. Yeah, so going into the advantages, pretty quickly, I mean, those are the most obvious advantages to tell us, okay, if we want to append data to a database, if we want to query data, or if we also want to save storage, it would be great to be as performant as possible, and time series databases are a good option here. Second thing is also the convenience functions that come with it, meaning we have data retention policies that are automatically applied for raw data, but also for different aggregates. So we can define many aggregates and have each of them kept for a different amount of time by the database, and also some further functionality like averages, quantiles, and so on that all come out of the box with a time series database. And last but not least, also scalability with multiple instances. Regarding limitations of time series databases, of course, the first limitation is if you only use a time series database, then you lack some functionality for StableNet to serve as a main database. You always need a relational database as well for the config data and metadata StableNet is using for its main functions. So we are limited in that. And also there are license limitations. Basically, depending on the vendor you use, you have different ones. So for InfluxDB, which is one popular database, for example, you have two different versions coming out of it. There's a free one that is basically just slower. So this is, of course, an important limitation. And the version 3, which is not slow, it performs pretty good, but also it costs quite a lot, depending on your use case and the size of the database. On the other hand, we compare timescale DB with it, which is an extension module for Postgres to enable time series support basically for Postgres databases, which also comes with two licenses with different limitations. There is again one license, the Community Edition, that has all of the features, same as with version 3 with Influx, but you have some restricted use, so you cannot sell this as a service, for example. And on the other hand, also same as with Influx, you have a license, the Apache 2 license that is unrestricted in use, but lacks some modern capabilities, and especially compression and hypercore features is what you want to have out of a time series database, because it's one of the main advantages. So yeah, this is basically the license limitation coming with timescale. But since we do not want to sell timescale as a service for now, we decided on testing with this exact version because we get all of the features and at no cost at the moment. Yeah, so what do we want to achieve with the database? Now that we know what are the advantages of it and what are the disadvantages. Of course, we want to improve our performance in as good as possible, especially on large data sets. But we also wanted to provide a better way to for external tools and also for scripts to access our aggregated data. So you don't always want to have external tools querying, for example, a REST API of StableNet, getting all of the raw data and doing some calculations afterwards. It's way better if you have like an additional database you can write data to and somebody else uses it directly from there. Also, which somehow is the same as with the performance argument that you say, okay, we have typical reporting use cases that, for example, have lots of measurements. If you do top-N calculations, maybe of all of the measurements you have in the system, or quite a lot of them, it might take quite a bit of time and also causes lots of load on the server. And we hope to reduce this load. And also we want to reduce this load not only by using a more performant database, but also by offloading the load to an additional database so that you are not even required to do the calculations on the main database independent of which one it is. Yeah, and this is basically the use case and what we leveraged to actually get to our goal is to use external data sources. External data sources is a feature that is already present in StableNet for quite a long time. And we simply improved that one to serve our purpose. And this is where I want to start my live demo, showing you how you actually set this external data source up and how this shows then in the portal. So starting off with some config files, of course, but it's not so much configuration. So the first thing, of course, with every external data source you use with StableNet is you need to deploy the data source. So there is this deploy folder for the data source, and this is basically the deployment. So you may already notice if you have ever configured an CMDB and have used it in StableNet, for example, then this is exactly what you do. You have a data source and put it in the deploy folder. The only difference, of course, is since we are using timescale database for now, we have a different database driver in here. And yeah, the database is running on localhost, as you can see. Of course, different pool name that is fitting, but rest of this is standard stuff. So not so much new for this. And the second thing is the actual configuration then for the export to this data source. So if we have a look, this is also not so much configuration that needs to be done actually. Of course, you need to define the data source you are using. You can also configure all of the aggregates. So in this case, we want to keep the raw data that is exported to this database for 30 days. We want also to have hourly aggregates and store them for 90 days. And we want to have daily aggregates that are stored for a year. With this config as is, we would basically export all of the measurement data to this external data source as well. We could now, if we wanted to, filter this with a tag filter in tag filter query language. This would be an example filter where we filter on interfaces and on template type interface, meaning all of the interface measurements would then be also transferred to this external data source. Yeah, this is basically all of the configuration that's needed, where you also see how you configure it and what are the possibilities. And in the portal, you can see it, I think, best if we simply do an analyzer plot. So right here, if you have an analyzer plot where you have number of processes. In this case, the blue chart is the one that is quite fluctuating, and maybe do 7 days. And now it's really simple. You simply select a different data source. So the one right here is our default data source. So this is the internal database, but you can also select a timescale data source. And since we configured 3 aggregates, we can also select the aggregate. So if we, for example, select our hourly aggregate, then without changing anything else, the curve changed because the raw data is now different, is already aggregated to our needs, no additional computation needed on the StableNet server side. And if we put it to daily, of course, then yeah, we see there is not really anything happening right now. The average is quite constant. Yeah, so this is the idea. I mean, in the analyzer, it's nice to have, I would say, but this really gets interesting if we start building large reports where we actually want to calculate lots of analyzer plots of larger aggregates, and then we simply use a different data source, use the correct aggregate already, and since it is on the fly always calculated in the database, then we yeah, don't take too much of a performance hit when generating reports. Yeah, this is basically the data source part, how it looks like, how you can configure it, and how you can use it. But via the same or a similar functionality, we leverage when exporting data to an external data source. We also can export data on a Kafka bus. So it's even less configuration actually to show you. So there is no deployment needed. This comes out of the box. We simply have one config file right here that tells us where we want to export Kafka data to. So if we have a look into this file, we simply see, okay, there is some SSL stuff, authentication stuff, and that's it that you need to configure. Because as Marius already showed in this previous in the previous keynote, we don't only have this export, but we also have an import because it's a bidirectional interface in this case. So we also need to configure the importer, so the consumer on the StableNet side basically, and yeah, it looks the same. That's just some Kafka properties. With those config files in place, the StableNet knows where to find the Kafka broker, and the Kafka broker, of course, installed, in our case, locally on the system. Now, all of this is set up, basically. So StableNet is now producing on some defined topics, measurement data and other data, and putting it on the broker. And we can have a look what it is doing actually by using this is the standard console consumer that comes with every Kafka installation. And as you can see right here, we simply subscribe the measurement data topic in this case on the correct broker. And if we start consuming now and wait basically for the next importer interval, we will then see some raw data. There are also other topics with some measurement metadata, but this topic right here, as you can see, let me stop this one, is just really min-max average, interval, timestamp, and measurement ID and metric key, because we export one entry per metric. So you would have, as you can see here, multiple messages for one measurement, actually. But we can not only consume, we don't only have this measurement topics, we also have alarm topics. So it's this alarm data topic. We can also listen on this because StableNet also produces messages on this topic. And for this, we may want to actually do something with our alarms. So maybe acknowledge one. And wait for the alarm calculation to take place. And then we will also see alarms produced to this topic. The difference is with the alarms that they are way more complex. So the messages are quite large. That's why I selected an alarm without a symptom. So the symptoms are empty in this case. You have all of this information on the open alarm. You see the comment we did, and you also have an action update that tells you what happened since the last time this alarm was put on the Kafka bus. Yeah, so much for consuming events that StableNet is exporting on the Kafka bus. We can also produce data. So the produce data from the outside and have StableNet consume it, to put it in the correct terms. And for this, there is also a topic available in StableNet, this external data topic. The special thing with this topic is that it actually requires our proprietary format we use for external measurement data at the moment. So I will maybe put an example also in here. So this would be an example. And as you can see, this is our format where you have the measurement keys, those four. You have the template name, you have the timestamp that is now automatically set by the agent, the interval, and then measurement data 5, 15, and 36. Because this host template requires 3 outputs. And this is something we can now have a look at. I already have it open in here in this demo. So this should be the correct measurement. As we can see right here, we have the keys and they match. And if we now create a chart for this, and of course, use the default data source to have the raw data back again, we should see some measurement data. So yeah, as we can see right here, those are tests from this morning, but this is our correct message with 5, 15, and 36, the 3 measurement values we sent in. Yeah, so this is also possible via more or less the same interface. And this concludes basically my presentation, showing you how you get data out of StableNet in different ways, how you can leverage time series databases, and how you also can get data back into the StableNet. Thanks for your attention.